My name is Emily McGrath. I am the Director of Workforce Development at NextFlex, and thank you for joining us here today. We are going to talk through the major challenges associated with the manufacturing workforce, with a particular emphasis on how we can incentivize diverse populations to participate in the manufacturing talent pool, and of course those specific challenges that NextFlex, an institute focused on flexible hybrid electronics, is facing. So before we dive into the STEM workforce, let's take a look at how the United States is performing in science and technology in general. And there is good news there. We are the global powerhouse in innovation by just about any innovation metric you'd care to use. R&D expenditure by government or industry, patents filed, papers published, venture cap invested, rate of technological progress, technology adoption. There is a long list. We are not necessarily number one at the top of each of these lists, but that is irrelevant. The real key to innovation success is commercialization. And the United States legal, regulatory, and financial environment is unlike any other in the world. What it does at the end of the day is allow people with good ideas to bring those products to market. Our position as the global leader in innovation is fundamentally enabled by a STEM talent pool of 36 million workers. These are the people who drive our success in science and technology. Despite the size of this talent pool, industry analyses report large existing skills gaps and are predicting that those skills gaps will grow over the next decade. Our STEM talent pool is fundamentally driven by two sources of talent. One is attracting foreign talent, and the second is educating domestic workers, domestic students. Attracting foreign talent is not really under the purview of the MIIs, but foreign workers play such an important part in our STEM talent pool that in order to create effective approaches to domestic talent, we have to understand the interplay of these two groups of workers. You can see from the funnel on the slide here that over 3/4 of engineering students are going to drop out of the program before they graduate. A lot of those actually drop out their freshman year. And of those who do go on to successfully graduate with a bachelor's degree in an engineering discipline, only 25% of them are going to go on to earn an advanced degree. This is a very, very narrow talent pool. For comparison's sake, China is graduating about 1.3 million engineers per year, and even when you normalize by population size, they're graduating about 2.25 engineers for every one that we're graduating in the United States. The subject is actually far more complex than that. Quantity alone is not the issue that we need to focus on. It's much broader than that, but it does give you a basic way to benchmark the number of people in our country, or the percentage of people that we are recruiting successfully into this field. One of the main reasons for that incredibly narrow funnel that we have in the United States when it comes to engineering is that our engineering talent pool is very shallow and highly homogenous. The sector is overall about 85% male and 85% either white or Asian. In other words, other communities in the United States are really not participating in the sector at the rate that we would hope to see. If you break this down by different demographics, you can see that many other demographics, white women, Black women, Native American men, etc., are underrepresented by between 65 and 455%. This number doesn't actually mean a lot when I look at it. I don't really know what being underrepresented by 455% means, which is actually the underrepresentation of Black women in the STEM sector, or in the engineering sector, I should say. So we looked at this a different way, which is just like this. As you can see from the slide here, 1 in 5 Asian males is earning an engineering degree, while 1 in 179 Black women is earning an engineering degree. You should also consider the fact that Asian men have a roughly 75% attrition rate when it comes to engineering disciplines. In other words, 4 of 5 Asian men have enrolled in an engineering degree. Black women have an attrition rate of roughly 83%, so more than one did enroll in the program, but only one is successfully graduating for every 179 Black women. What the main takeaway from this data should be is that if you want to grow the size of the STEM pool, you literally have to start talking to underrepresented communities, starting with Black women, Black men, Native American women, Native American men, Hispanic women. These are all groups that are really, really, really underrepresented in the STEM sector. There are a lot of reasons for this. I'm not going to get into all of them today, but one of the main drivers for underrepresentation in a lot of these communities is poverty. We know that there is a direct link between poverty and educational attainment and success in any field, particularly STEM fields for students. We also know that poverty affects different demographics very, very differently. And our Black communities and our Native American communities are really disproportionately affected by poverty, which is one of the reasons we see that lack of participation in the STEM sector. Women are also highly underrepresented in the STEM workforce overall, particularly within engineering. There are, again, a lot of reasons for this, but if we want to address this issue, fundamentally, we're going to have to change the way that we recruit and retain women within the workforce. There's a lot of interesting data that, if you look at it, shows you, how many women are earning degrees, how many women are going on to use those degrees in the workforce, and then at what point they are dropping out of the workforce. And again, we're not going to go into all of this right now, but the main takeaways here are that recruiting from smaller universities with more diverse populations is a really effective way to engage women in the workforce. A lot of women choose to go to smaller universities closer to their hometowns than the big 10 universities where a lot of the engineering workforce is pulled from. And then the second thing that we can do to really retain women in the workforce is provide on-site childcare. One of the main reasons that women drop out of the STEM workforce is because it requires a lot of on-site time, particularly for those engineering disciplines like mechanical engineering or chemical engineering, where off-site work really isn't an option. You have to be able to access a lab or use really high-powered computers that don't work the same way from home, et cetera. And women want to be near their children. If you make women choose between being employees and being mothers, they choose to be mothers if they have any option in the matter at all. We also want to talk about technicians, because the issues around attracting and training engineers are really, really different than the issues around attracting and training technicians. Technicians represent one of the largest skills gap in the advanced manufacturing sector. And one of the main reasons for this is that the jobs, particularly at the entry level, are not all that attractive, particularly to today's young people who are looking for very different things in their jobs and careers than people were 20, 50 years ago. When we talk about the manufacturing workforce, one of the things that we need to do is look at the issues with the engineering workforce and the issues with the technician workforce differently, because there are really different problems involved with both, or really different challenges, I should say, involved with both. There is a much larger skills gap when it comes to technicians than there is to engineers, and there are a lot of reasons behind that. Technician jobs fundamentally are not aligned with what today's young people are looking to see, and there are a number of reasons for that. One is the wages, particularly at the entry level, are highly uncompetitive. Manufacturing companies frequently benchmark entry-level wages with minimum wage, which is really not the metric that they need to use. The correct metric that they need to consider when they're looking at how to attract people into their workforce, entry-level technicians, is what is Burger King paying? What is Target paying? What is Walmart paying? And then, as far as I can tell, you need to go about 25% above that. That's table stakes for this game right here. Anything below that, and young people are going to look at the opportunities and they are going to choose to go to Target instead. Another barrier to entry for young people into technician jobs is really the nature of the work itself and the work environment. Manufacturing work, even when it pays at the same level as, another employer like Target or something, it is generally much, much more complex. People are doing, very precise operations on using, robotics or manufacturing lines, things like that. Whereas at Target, they can just be stacking shelves, where you have the opportunity to send a text or answer a call discreetly if it comes in. That's not an option in a lot of manufacturing environments. Not only that, the requirement to be there on time is taken much more seriously. Frequently, you are part of a workforce that is running a production line, and the shift starts at a certain time. And if one of your workers is missing, that shift can't necessarily start, or it won't have the same production that was estimated. So people who arrive late, frequently more than twice, are often fired. Whereas at Target, if you show up a little bit late, it's not as big a deal. It's not great. People don't like it, but it hasn't, shut down productivity for that day in the same way. So that's another big issue. Lastly, the schedules are highly inflexible because you have a manufacturing environment with a production line. There is a need to be on site. You can't run with a skeleton staff. You need that full complement of workers. And so giving people time off or letting them go a couple hours early is much more challenging for manufacturers than it is for other employers. The key takeaways from this presentation are a couple things. The first is that there is virtually no way to grow our STEM talent pool without broadening participation to underrepresented demographics. That means we need to pay particular attention to the specific hurdles and challenges that are keeping members of those communities out of the STEM talent funnel. This is really important. The reasons that Black women are not participating in the STEM sector the way that Asian men are very different. And so if we want to attract and support and bring these communities into the fold, we are going to have to fundamentally change how we are handling outreach, engagement, recruitment, and training. There's no way around that. The second is that poverty is one of the biggest predictors of academic success. Like you saw on that slide, 30% of the nation is living in poverty. Even if you don't have a moral issue with this, you should have a strategic issue with this, because what we see from that is that people who live in poverty fundamentally have a much lower chance of joining the workforce in a way that will help drive American prosperity and all of the benefits that we enjoy from that. So poverty is a problem that is holding the nation back. We need to get a handle on it. And the last one is that if we want to incentivize worker retention, particularly for those demographics that are most underrepresented in STEM and manufacturing today, we are probably going to have to change how we think about employment and compensation. We see that what really matters today, in addition to compensation itself, are things like flexibility, benefits like on-site childcare. These things will have to become routine for manufacturing employers if they want to broaden participation to those demographics who are most underrepresented and therefore grow the size of the talent pool. So now we're going to move on to the second half of the presentation, which is really going to be how NextFlex has used this data to inform our workforce development strategy, our portfolio of programs, and how and where we've decided to deploy those across the United States. Let's start with our goals. All the MIIs have the same goals, which is basically to facilitate the creation of a world-class manufacturing workforce with an aptitude for innovation, with the diversity of thought and the technical agility to sustain the country's position as a global leader in science and technology. This is fundamental to our mission and our identity as an MII. And the second is, of course, to achieve that broad participation in the manufacturing workforce, which we've discussed is such a clear part of our ability to create a talent pool capable of continuing to fuel U.S. prosperity. With those goals in mind, the NextFlex has stood back and taken a look at what we think that the market is going to look like for FHE and advanced packaging, which is our technology focus areas. Over the next 5 years, in response to federal incentives and market opportunity, we are estimating that we're going to need about 25,000 new workers between 2024 and 2029 over the next 5 years-ish. We predict that these workers are going to be largely clustered in 10 states that have varying levels of manufacturing activity focused on FHE and advanced packaging. Some of these markets are fairly mature, some of them are very nascent, but those are the areas where we see real opportunity for growth. We think that that number of workers, the 25,000, is going to be hired or grow in a fairly steep line, beginning with about 1,500 the first year and then moving up to close to 10,000 the fifth year. At that point, we predict that growth will be fairly stable, requiring 3 to 5%, job openings per year, which probably looks somewhere in the nature of, 1,500 new workers every year, or new positions that need to be filled or backfilled as a result of attrition or workers retiring out. The other thing that we know about FHE is that there's very specific disciplines that are going to be in high demand. These disciplines include mechanical engineering, electrical engineering, chemical engineering, materials science, computer science, and applied physics. These are hot disciplines for a lot of different technology areas, so there is a lot of competition for people with those backgrounds, particularly with people with advanced degrees in those backgrounds. And lastly, as you can see on the slide there, we've roughly projected demand by degree, and you can see that we're going to need a fair number of technicians who are going to be working in both design and manufacturing environments, and then we're also going to require bachelor's, master's, and PhDs. This mix of engineers and technicians is going to be really important to our continued progress because each of these groups plays a different role in innovation, design, and scaled manufacturing. Closing the gap is going to be very challenging for NextLex and for most other technology areas. You can see there that if you want to place 7,500 technicians, you need to be recruiting about 80,000 people into that pipeline. That's going to be a mix of both students and adults. The conversion rate of a K-12 student reached through an awareness building or engagement program into a enrolled student in a post-secondary technician training program to placement. That conversion rate for a K-12 student is fairly low. Depending on your approach, if you take a very surgical approach and you're working with students who are more likely to consider technician careers, i.e. like CTE classes or something like that, you might see 5%. If you're just scattershot talking to every student in a given market, it's closer to 1% or lower. Adult populations have a higher conversion rate. If you work through your workforce investment board to reach out to adults in the area who are looking for jobs, you see a conversion rate that's usually between 10% and 20% in those post-secondary programs with job placement. The issue is that K-12 students are really easy to find. You know where the high schools are. Adults who are looking for jobs are much harder to find. You need to work through a workforce investment board or some other type of organization that is in touch with adults who, again, are seeking employment opportunities, but there's much lower numbers. So you can go with K-12 and see a low conversion rate. You can see a higher conversion rate if you work with adults, but that's a smaller population to begin with. Engineers, if you look at that conversion funnel from recruitment activities all the way through placement, you can see here that we need to talk to about 400,000 students, let's say high school students, if we want to eventually train and place about 17,500 engineers at all levels, bachelor's, master's, et cetera. That's, again, going to be a tough road to hoe. It involves, of course, thinking about the mix of foreign talent. When you look at that as well, there's a lot more foreign students participating in engineering programs once you get past bachelor. So the mix of foreign to domestic students goes up considerably when we start talking about master's and PhD programs. At NextLex, given what we see are the biggest hurdles to workforce development for the STEM and manufacturing sector, we've identified a series of opportunities that we think are most likely to lead us to success in workforce development. This includes, of course, expansion in participation. So we're looking at growing that base of qualified workers by targeting directly those communities who are most underrepresented, both adult and K-12 populations, and then, of course, using a sector partnerships approach to ensure that we do that most effectively. What I mean by that is that when you are working in a given market, you not only want to work with K-12 districts, you want to work with the K-12 districts where you see the most diverse and underrepresented students. And to ensure that your impact on them is as great as possible, you want to make sure that you are working with the community partners who address some of the challenges that we talked about earlier. So that's going to be community-based organizations that address poverty. That's going to be, STEM and tutoring organizations that provide additional resources and supports to students who may not be getting them at home. These are really, really important components of an approach that is likely to have maximum impact on those populations you're intending to serve. The other thing that we are doing is creating standardized and turnkey learning materials for both training and upskilling purposes, focused on flexible hybrid electronics. We're also making sure that these programs are digital and asynchronous so that we allow both students and workers maximum flexibility in accessing and learning from these materials. And then lastly, what we want to focus on is employer engagement and identifying best practices and making sure that we are training employers in what may be holding back workforce development for them, what may be stopping specific communities and groups from participating in their workforce, and helping them understand how they can address that through things like providing on-site childcare, working with a more flexible schedule, providing more time off for workers. This is particularly important for workers with less than a bachelor's degree, who frequently, in addition to being compensated at the lowest levels, have the least amount of flexibility. So, using this approach, NextFlex has built out a portfolio of learning programs. We begin with K-12. We go all the way through the incumbent workforce. We focus on recruitment, training, and upskilling as our main activities. You can see there. FlexFactor is our most mature, most built out, and most proliferated program. It is currently being deployed in 13 states across the nation and has already reached over 12,000 students. Then we have Flex to Future, which is a learn and earn program designed to ensure that students who are in work-based learning experiences are getting maximum value from those programs, being professionally developed and understanding not just the hard skills that they need to transition successfully into a manufacturing job, but the soft skills as well, which employers cite across the board as absolutely key to career success. Flex Ahead and Flex Pro are our two newest programs. They're in development. These two programs are that asynchronous digital content that I was referencing earlier that provide the opportunity for people to upskill on their own time, which is really critical, especially when you're talking about the incumbent workforce. I want to spotlight sector partnerships, which you heard me talk about a couple of minutes ago, because they are such an important part of success in workforce development. Workforce development is fundamentally a series of activities that involve organizations that are frequently rather siloed from another. You need to bring government into the fold. You need to bring education into the fold. You need to bring industry. You need to bring community-based organizations, potentially the military. And if you don't have an approach that allows all of these groups to work together really effectively, and that is the goal of the person in charge of the workforce development or the group in charge of the workforce development, you don't see the collective impact that you could. So when we talk about workforce development here at NextFlex, one of the most important things that we do is step back, look at which groups we want to bring to the table, and think about how we can structure an activity that allows each group to participate in the way that is natural to them. We want teachers to be teachers. We want the government to perform government roles supportive of education and industry. We want community-based organizations to provide those additional resources and support that they provide, et cetera. We want industry to be industry. And so when we create activities, we allow each organization to stay true to its identity and yet participate in something that at the end of the day is going to be bigger than the sum of its parts. FlexFactor is a fantastic example of this. This is a project-based learning program for K-12 students designed to expose them to advanced technologies, to entrepreneurship, into education and career pathways in manufacturing. During the program, small groups of students work together to identify a real-world problem, to conceptualize an FHE-enabled product that will address that problem, to build a business model around it, and at the end to pitch it to a panel of representatives. Along the way, students actually go to a manufacturing facility where they get a tour of that facility, and they get to see what it's like to work in advanced manufacturing. They get to see clean rooms, they get to see advanced robotics, they get to see products and the way that they're used and how they change the world. This is really impactful for students. The following week, they get to go to a college campus and they get to learn about the education pathways that lead back to the careers that they saw the week previously. This has a very inspirational effect on students, and it involves all of the groups that I previously mentioned, and it allows them to participate because industry is being industry. They're providing a tour of their industrial environment. Teachers get to be teachers, they get to teach. So approaches like this are particularly impactful when it comes to workforce development. Another program that we are immensely proud of here at NextFlex is our Advanced Manufacturing Technology Technician Training Program. This is a program that we have launched via a National Science Foundation grant in partnership with Evergreen Valley College. There are a lot of technician training programs across the United States. This is a popular endeavor. There are a lot of grants that fund these sort of activities. We took a different approach. Our curriculum was literally written by industry members. We took industry engineers and technicians, brought them to the table, and asked them to create the courses themselves. So we know that what students are learning in this program is exactly what industry wants to see and not what community college instructors or professors are guessing that industry wants to see. And we know that it's current because it was written in the recent past. Not only that, but the courses are actually taught by industry-based adjuncts, which means most of them are taught at night, but they are taught by people in industry. So they are learning the most current skills, and most of them are taught on site at the industry facility. So not only are students learning curriculum that was written by industry, not only are they learning from current engineers and technicians who are in the workforce today, but they are learning on site at the manufacturing environment. And this is absolutely key to the outcomes that we see, which is a really, really high conversion rate from enrolled student to placed employee. Our students are performing so highly as a result of this approach to education that they are frequently hired within a course or two and then allowed to continue through the program while they are already at work and getting paid to be there. This is actually a really, really important point because a lot of students who are pursuing technician pathways don't have a lot of resources. So the opportunity to get paid while you work, to get paid to work full time, is really game changing and what fundamentally allows them to stay in both the educational pathway and then enter the workforce. This approach has worked incredibly well for NextFlex. We have not only built out impactful programs, we have scaled them across the United States. Our programming is being deployed in 13 states, and we have reached over 15,000 participants to date. The vast majority of these participants have, of course, been part of FlexFactor, our, as I mentioned earlier, our most mature and built out program. But the other thing to note is that all of these participants have received a significant amount of educational content as measured in hours. These aren't people who passed by a table at a convention hall and got a 15-minute spiel. These are, people who dug deeply into FHE and advanced technologies and learned not only about the technology, not only about how it's designed and manufactured, but about how it can be deployed, about how it can change products and it can change lives. And these are the things that we really want people to come away with when they interact with our programming, a really fundamental understanding of FHE and how it can be used to transform manufacturing and products. The other thing that I want to say quickly before we close is that as a part of our approach to workforce development, NextFlex has focused heavily on reaching those groups that are most underrepresented in manufacturing today. You can see from the slide there that almost 40% of those 15,000 participants have been women, 61% have been underrepresented minorities, 50% have been low-income students, and 8% have been military-connected students. 8% is actually a very high number because only 1% to 2% of students nationwide are military connected. We have achieved this through using that sector partnerships approach that allows us to work with those stakeholders who ensure that we reach those groups that are most underrepresented, and you can see that the metrics speak for themselves. In closing, I'd like to invite you to reach out to NextFlex if you have any interest in participating in any of our programs. We work with manufacturing communities across the nation to bring workforce development programs and industry expertise, and we would love to hear from you.